So when we're simplifying rational expressions, let's think back to when we would simplify fractions with exponents or divide with exponents. And one technique we used, when we had 32x to the fifth y squared over 4xy to the 7, we could have rewritten this as 32 and 1, 2, 3, 4, 5 x's and 2 y's over 4x and 1, 2, 3, 4, 5, 6, 7 y's. We factored it fully out and wrote every factor. That way, when it comes to reducing, we can simplify each term as it comes. And we see 32 over 4, that's like 8 over 1. So we have 8. Let's see, we have 1x on the bottom, that reduces with 1x on top, so we still have 1, 2, 3, 4 x's on top. And our y's, we have 2 y's on top, cancel with 2 y's on the bottom, and we still have y to the fifth on the bottom. We could have subtracted the exponents, but this is one way to visualize and see that we can reduce the same number over each other because that equals 1. X over x is 1. Y times y over y times y is 1, and we're left with what's there. Now, we need to remember when we simplify rational expressions, we can only simplify or reduce factors, which I'm even going to put in parentheses because that's often how we'll see it. We can only simplify factors, not individual terms. We cannot simplify individual terms. We can only simplify factors. What do I mean? So let's look here at x squared plus 8x plus 7 over x plus 1. Now, how in the world are we going to simplify this? Well, we're going to do it by factoring the numerator and the denominator. So in our numerator, we need to think what multiplies to 7 that adds to 8? Well, what multiplies to 7 that adds to 8? We can think that what multiplies to 7 and adds to 8 is when we can do x plus 7 times x plus 1. And we can say that that's all over the group x plus 1. Now, when we have this, we can look at the factors that are in common. We have an x plus 1 and an x plus 1 in the numerator and the denominator, so we can reduce those and we're left with x plus 7. And that's how we simplify this rational expression. So, if in the event that we see opposites, which we're going to see them in the next one, if we have opposites, we can factor out -1 to get the same factors. What in the world does that mean? Well, let's wait and see. 25 minus x squared over 8x minus 40. 25 minus x squared over 8x minus 40. If we factor in the top, we have another difference of squares, and we're going to have 5 plus x and 5 minus x. In our denominator, if we have 8x minus 40, remember we always need to start with the GCF, that we're going to have 8 times the group x minus 5. Now, look, we have x minus 5 and 5 minus x. Here's where that opposite factor comes in. So we have 5 minus x and x minus 5. Those are not the same, but they're opposites. What we can do is we can factor out a -1 and say that this is now x minus 5 over 8 times x minus 5. Then we have the same factor that we can reduce. So we can reduce there, reduce there. I'm going to bring that -1 into the denominator and say that we're left with 5 plus x over -8 as our simplified rational expression. So if we have the opposites, we factor out a -1 to get the same factor, and then we just have to make sure that we're careful with what we do with that -1 when we're done. Now, oftentimes what we're going to have to do is simplify and find the excluded value all at the same time. Now, remember from this last section, when we simplified the excluded values, we set the denominator equal to 0. We need to remember to find the excluded values from the original denominator. So, when we have 4x plus 16 over x squared minus 5x minus 36, what we're going to have to do is let's factor the numerator because we're going to simplify. So we'll have in the 4 times the group x plus 4. Always, always, always remember a GCF. GCF, always, always. 4 times the group x plus 4. Then in the denominator, we are going to have, think what multiplies to negative 36 that adds to negative 5. Well, what multiplies to negative 36 that adds to negative 5? We have x minus 9 times x plus 4. Now, let's take a quick second and pause before we reduce to find our excluded values. So we set this x minus 9 times x plus 4 equal to 0, so think x minus 9 equals 0, x plus 4 equals 0. So we can say that our excluded values are when x equals 9 and when x equals negative 4. Those are our two excluded values. Now let's go on and simplify. We have 4 times the group x plus 4 over x minus 9 times the group x plus 4. We can simplify those x plus 4's and be left with 4 over x minus 9. And again, our excluded values are 9 and negative 4. Now, from this final, we see that 9 makes sense as an excluded value. But we need to keep in mind what happens from our original denominator. Negative 4 is still an excluded value because our original expression, that negative 4 would make 0 or make our expression undefined due to a 0 denominator. Bummer. So for our practice for tomorrow, we're on page 1594, 18 through 29. 1594, 18 through 29. We start here with one kind of simple 15x to the 4th y squared over 40 x cubed y cubed. And we're simplifying and finding the excluded values. If we think 15 over 40, if we divide both of those by 5, we're left with 3 over 8. X to the 4th over x cubed, we're left with x. Y squared over y cubed, we're left with y in the denominator. Now, for our excluded values, we set this equal to 0. We set this equal to 0. Now, since they're all being multiplied together, we need to remember that any product or any factor of that product can equal 0 if the denominator equals 0. So since 40 doesn't equal 0, we know that our excluded values are when x equals 0 or when y equals 0. Now let's look at another one that might be a little more tricky. So if we have n squared plus 7n minus 18 over the group n minus 2, we're going to factor our numerator. So what multiplies to negative 18 that adds to 7? Well, that's going to be n plus 9 and n minus 2 over the group n minus 2. Quick pause. We need to find our excluded values when our denominator equals 0. So n minus 2 equals 0. Our excluded value is going to be when n is equal to 2. Now we go on and simplify our expression, and we're left with n plus 9 with an excluded value of when n equals 2. Take your time, review your factoring, send me an email if you have some questions, go to the math lab. You can do this. It's a culmination of everything we've been doing up to this point. Go Lions.